The Newton's rings experiment is also used to find the refractive index of the liquid. In order to find the refractive index of the liquid, we need two different set of experiments. One is with the air, which we were discussing throughout the videos. In the previous videos, we were discussing with the Newton's rings with the air film. And the second one, this one will be new. That is, our arrangement is inserted or immersed into a beaker which is containing some liquid. This liquid which we need to find the refractive index value. Okay. So this is the two experiments, the same experiment. So what happens is when the refractive index or some liquid is introduced between the glass plate and the plano convex lens, there will be some difference in the rings pattern. Okay. So in this case, we will be getting somewhat clear rings, and there will be when we are comparing these two rings, the difference is, in this case, when the refractive index or some density is introduced between the glass plate and lens, the pattern will be different. This pattern will be much bigger than that of this, and also the separation between the rings also decreasing. Okay, because as you already seen that the radius of the rings, the equation is root of Rn lambda divided by mu in this case, and here it is Rn is equal to root of Rn lambda. Okay. So here this refractive index playing a role. So you can see this value increases. There will be some changes to the radius. So this pattern will be bigger pattern. It will be clear pattern, and it is easy to do an experiment with an air film. But in this case, the rings will be very close to each other, and the diameter also will be less comparing to the air film. Okay, the diameter of the film will be less comparing to the air film, and this pattern is little tricky. It is a little bit difficult to, as the refractive index increases, it is more difficult to see or to observe and to calculate the value of the diameter. Okay, so we are going to derive the equation, which is there are two methods. Okay, one is a simpler method. Okay. So in this case, in the case of air film, suppose we have a radius which is equal to Rn is equal to root of Rn lambda, and Rn square is equal to Rn lambda. Okay. We are using same light source, we are using same plano convex lens. So both the radius of curvature and the wavelength will be same. So my value of the radius is, the radius of the nth dark ring is, suppose it is Pn, which is equal to root of Rn lambda divided by mu. Okay. And Pn square is Rn lambda divided by mu. Okay. So these are my values, and suppose I have the value of the 10th dark ring, R10 I have. So here R10 square is equal to R into 10 into lambda. Here this is also P10. So P10 square is equal to R into 10 into lambda divided by mu. Okay. So like that I have the same radius I have. So how to calculate? This is a very simpler method. So in this method, this is my equation number 1 and this is my equation number 2. Okay. So I have conducted an experiment with the same arrangement, but one is in air film, one is some liquid is introduced between the glass plate and the lens. I got two different patterns. So with the air film, my nth value, nth radius is Rn. For that liquid film, my nth radius is Pn. I have both the values, and I have Rn square. This is with air film, is equal to Rn lambda, and this is with liquid, which I have Pn square is equal to Rn lambda by mu. I have two equations, 1 and 2. How to calculate the value of the refractive index using this equation? That's what I'm going to do. So let's take, this is my equation number 1, this is my equation number 2. 1 divided by 2. So what I get? Rn square divided by Pn square, which is equal to Rn lambda divided by Rn lambda by mu. Okay. So this cancels. We will get Rn square divided by Pn square is equal to Rn square divided by Pn square is equal to mu. This is the simpler method. Suppose we have the diameter of same rings. Okay, so in this case, I am assuming this is my 10th ring and R10 is the radius of my 10th ring. Here also P10 is the radius of the 10th ring. So in that case, what I can do is I can simply square both the values. So I can simply square R10 square divided by P10 square and I can calculate, and dividing both I can calculate the value of the result. Okay. So this is one method. So there is another method which is because while doing this single value, the error may be there. By measuring the MSR and BSR, there is a possibility of error. So in order to avoid that error, so we need to take much more readings and we need to calculate the values. Okay. So for that, let's recollect the equation for the wavelength. Lambda is equal to, in the case of air, lambda is equal to d square n plus k minus t square n divided by 4kr. This was the equation. Okay. So this is in the case of air film. Okay. Suppose we have a liquid which is introduced between the two films. So we will, as I told you, we will get different values of radius, right? So Pn, which is the radius of the nth dark film, is equal to root of Rn lambda divided by mu, and Pn plus k is equal to root of R into n plus k lambda divided by mu. Okay, this is the radius. Okay, radius of the nth dark ring using some liquid. This is n plus kth, radius of the n plus kth dark ring using some liquid. So now we need to find the diameter. Okay, so here we have the equation of lambda in terms of the diameter. So here also we are going to do the same. So here, suppose this is the radius and I am taking diameter is equal to Q. Okay, Q is the diameter. So Qn is equal to 2 into Pn, which is equal to root of 4Rn lambda divided by mu, and Qn plus k is equal to root of 4R into n plus k lambda divided by mu. So here in this case we have Qn and Qn plus k. So how to calculate the wavelength? We can have Q square n plus k minus Q square n is equal to what we will get, 4Rn plus k lambda by mu minus 4Rn lambda divided by mu. Mu is common, so we can take this side. So we will get mu into Q square n plus k minus Q square n is equal to 4Rk lambda, and lambda is equal to Q square n plus k minus Q square n into mu divided by 4kr. Okay. So that is the equation in the case of liquid. The equation for the wavelength is Q square n plus k minus Q square n into mu divided by 4kr, where Qn plus k is the diameter of the n plus k dark band and Qn is diameter of the nth dark band. Okay. So this is my equation number 1 and this is my equation number 2. Both are equal to some wavelength lambda. Okay. So I am going to equate this equation number 1 and 2. So what will I get? So while equating the equation number 1 and 2, I'll get d square n plus k minus d square n divided by 4kr is equal to Q square n plus k minus Q square n divided by 4kr into mu. So this cancels. Therefore, mu is equal to d square n plus k minus d square n divided by Q square n plus k minus Q square n. So that is how to calculate we can simply find, okay, while doing this experiment to find the wave refractive index of the liquid, we will be conducting one experiment with the liquid and one with the air film. So we will be getting a number of values of diameter in the case of air film. Also, we will be getting a number of values of diameter in the case of liquid film. So what we can do, we can simply by using this equation, that is simply the equation for the diameter, we can calculate the refractive index of that particular liquid.